At the end of this video, you should be able to summarize how Earth's rotation and revolution provide a basis for measuring time. Chapter 26, Section 2, Measuring Time. Earth's motion provides the basis for measuring time. For example, the day and year are based on periods of Earth's motion. The day is determined by Earth's rotation on its axis. Each complete rotation of Earth on its axis takes 1 day, which is then broken down into 24 hours. The year is determined by Earth's revolution around the Sun. Each complete revolution of Earth around the Sun takes 365 1/4 days, or 1 year. A month is based on the Moon's motion around Earth. A month was originally determined by the period between successive full moons, which is 29.5 days. The word month actually comes from the word moon. However, the number of full moons in 1 year is not a whole number. Therefore, a month is now determined as roughly 1/12 of a year. Formation of the calendar. A calendar is a system created for measuring long intervals of time by dividing time into periods of days, weeks, months, and years. Many ancient civilizations created versions of calendars based on astronomical cycles. The ancient Egyptians were the first to use a calendar based on a solar year. The Babylonians used a 12-month lunar year. The Aztecs, who lived in what is now Mexico, also created a calendar, which is shown on the screen now. Because the year is 365 1/4 days long, the extra 1/4 days is usually ignored to make the number of days on the calendar a whole number. To make the calendars on the same schedule as Earth's movement, we must account for that extra time. So, every 4 years, 1 day is added to the month of February. Any year that contains an extra day is called a leap year. More than 2,000 years ago, Julius Caesar of the Roman Empire revised the calendar so that an extra day every 4 years was added. His successor, Augustus Caesar, made the extra day come at the end of the shortest month, February. He also made July and August long months with 31 days each. The modern calendar. Because the year is not exactly 365 1/4 days long, over centuries, the calendar gradually became misaligned with the seasons. In the late 1500s, Pope Gregory XIII formed a committee to create a calendar that would keep the calendar aligned with the seasons. We use this calendar today. In this Gregorian calendar, century years such as 1800 and 1900 are not leap years unless the century years are exactly divisible by 400. Thus, 2000 was a leap year even though it was a century year. However, 2100, 2200, and 2300 will not be leap years. Time zones. Using the sun as the basis for measuring time, we define noon as the time when the sun is highest in the sky. Because of Earth's rotation, the sun is highest above different locations of Earth at different times of day. Earth's surface has been divided into 24 standard time zones, as is shown on the screen here, in order to avoid problems created by different local times. In each time zone, noon is set as the time where the sun is highest over the center of that zone. Because Earth is nearly spherical, its circumference equals 360 degrees. If you divide 360 degrees by the 24 hours needed for one rotation, you find that Earth rotates at a rate of 15 degrees per hour. Therefore, each of Earth's 24 standard time zones covers about 15 degrees. The time in each zone is 1 hour earlier than the time in the zone to the east of each zone. International Dateline. There are 24 standard time zones and 24 hours in a day. But there must be some point on Earth's surface where the date changes. The International Dateline was established to prevent confusion. The international dateline is a line that runs from north to south through the Pacific Ocean. When it is Friday west of the international dateline, it is Thursday east of the line. The line is drawn so that it does not cut through islands or continents. Thus, everyone living within one country has the same date. Note where the line is drawn between Alaska and Siberia. Daylight savings time. Because of the tilt of Earth's axis, daylight time is shorter in the winter months than in the summer months. During the summer months, days are longer so that the sun rises earlier in the morning when many people are still sleeping. To take advantage of that daylight time, the United States uses daylight savings time. Under this system, clocks are set 1 hour ahead of standard time in April, which provides an additional hour of daylight during the evening. The additional hour also saves energy because the use of electricity decreases. In October, clocks are set back 1 hour to return to standard time. Countries in the equatorial region do not observe daylight savings time because there are no significant changes in the amount of daylight time in that equatorial region. Daylight is about 12 hours every day of the year. At this point, you should be able to summarize how Earth's rotation and revolution provide a basis for measuring time.